All right, guys, here we go. We're going to start looking at graphs of the secant, cosecant. Let's remember just looking at the graph of the sine for now. Because here's a graph of our sine, as we well know, okay? Intercepts, okay? Right there, pi, 2 pi. High points, pi over 2, 3 pi over 2, our low point. Now, I'm going to ask for what is the graph of the reciprocal of the sine of x. That is 1 over the sine of x. Well, just take the reciprocal of each point. Reciprocal of this point is going to be itself because the reciprocal of 1 is 1. At pi over 6 down here, we're going to have a value of 1 half. 1 half right about there. Okay. So we know its reciprocal is going to be, okay, 2. So if I graph the reciprocals, there's my graph. And in graphing the reciprocals, okay, like I said, okay, if I have, let's just put in here, okay, x equals pi over 6, pi divided by 6, okay? So here's my pi divided by 6. Yeah, right there on the sine graph is 0.5. But the reciprocal of 0.5 is 2, which is the graph on the reciprocal graph, which is the graph of the cosecant. So, lo and behold, 1 over sine x is the same as the graph of the cosecant x. Take away the sine, there's my cosecant, which is the same as 1 over the sine. All right? So, what do we know about this? Well, okay, first off, get back to the sine x. Wherever the sine x is equal to 1, all right, wherever the sine of x is equal to 1, the cosecant is also equal to 1. Right there. That's pi over 2. Likewise, wherever the sine is equal to negative 1, this cosecant is equal to negative 1 as well. But if we can see, the graph of the sine, of course, has a range from negative 1 to 1. The graph of the cosecant has a range of everything except from 1 to negative 1. So we would say the range of the cosecant is, okay, from negative infinity up to negative 1, and from 1 on up to infinity. So the range of the cosecant is everything but the range of the sine, as you can see right here. So the range is from negative 1, the range is from 1 to infinity and from negative infinity to 1. Now, what also happens is we've got these periodic asymptotes, okay? Here's my asymptote right here. Here's another one at 2 pi. Where do the asymptotes occur? Well, the asymptotes occur where the sine is equal to 0. So wherever the sine is equal to 0 is where my cosecant has its asymptotes. Again, wherever the sine is equal to 0 is where my cosecant is going to have its asymptotes. So in other words, we have interruptions in the domain of the cosecant. So we would say that the cosecant has a domain of everything except multiples of pi, since it is at the multiples of pi where the sine has its intercept, okay? It is the multiples of pi where the cosecant is undefined, okay? So, in summary, with the cosecant, and we'll come and do another video with the secant, we would say that the cosecant is, by definition, the reciprocal of the sine. And that the range of the cosecant is from negative infinity to negative 1 and from 1 on up to positive infinity. It is defined everywhere that the sine is not, okay? Or, from the other token, wherever the sine is defined is where the cosecant is undefined, okay, in terms of its range, okay? In terms of its domain, the domain, okay, of the cosecant is determined to have, as we can see, all these periodic asymptotes. Where did those asymptotes occur? Those asymptotes occur at the values where the sign is at 0. So, okay, beginning, middle, and end of the sine function defines where the asymptotes are, or defines where the cosecant is undefined. Again, where the sine is equal to 0, the intercepts of the sine are analogous to the values for which the cosecant is undefined. Okay? So we'll come back and talk about the secant in just a moment.